So, biomedical design as it exists at UCC is a concept where we place interdisciplinary teams of students, place them with a clinical mentor, consultant level physician, to solve a real clinical problem over the course of a single semester. Now, similar programs exist around the world. What makes what we're doing at Cork quite different is two particular aspects. The first is we don't just give the students a problem and tell them, okay, you go solve the problem. We give them a methodology, a toolbox by which they can actually come by the solution, and that's the theory of inventive problem solving, or TRIZ, which my colleague John McSweeney does a fabulous job in imparting. The second respect in which we differ is that we don't just place engineers in the team, we embed or seed each team with at least one medical student. Now, that has been a very interesting experience from a number of perspectives, but most notably, I get engineering students coming back to me saying, you know, I learned more from that medical student than I did from the engineers on my team. Now, the positive feedback and everything has been wonderful, but the most important thing I think is that we've been recognized internationally. We're now part of the BioApp consortium, which places us as the lead partner with several other European institutions, places like Leuven and Semmelweis and the Open University in the Netherlands, as well as some Irish SMEs, to develop a framework which will allow innovation in biomedical devices to be embedded within undergraduate curricula around Europe. We won the UCC President's Award for Teaching this year, and most recently Enterprise Ireland, the state body responsible for promoting innovation in this country, has selected one of the projects coming from the module for future commercialization.
The theory of inventive problem solving was first published by Henry Altshuler in 1946 in Russia. This is a systematic method for coming up with inventive solutions to very tricky problems. When we applied TRIZ to the clinicians' problems in our biomedical design module, we challenged our fantastic medical students and our fantastic engineering students to think differently, to think in a systematic way and come up with lots of different solutions. The way it works is we take the actual localized problem and we express it in terms of TRIZ. Then we apply TRIZ methods to come up with lots of different solutions. And we apply those and bring them back down locally. And one of our greatest challenges, of course, was to actually select which of the many solutions we came up with would have been the champion solution or the best solution in terms of prioritising a way forward.
One of the projects being undertaken by the Tel for Health research group at UCC is the BioApp project. It's a good exemplar of the type of project that we would like to undertake. Currently, we're 1 year into a 2-year project. It's led for UCC by Drs. Padraig Cantillon Murphy and Colm O'Tuig. The reasons that it matches the intent of the research group overall is that we see in it the potential to have impact in the real world. BioApp takes original ideas, filters them, interrogates them for feasibility and for importance, and then continues to allow those develop and supports the development towards ultimately a commercially viable product. What's particularly attractive to us is that it represents the kind of collaboration between a group of engineers and medics, students in this case, supervised by senior academics and senior clinicians, in such a way that the expertise of both sectors is used to best effect. That, we feel, is something that has been missing, for instance, in the development of medical devices or in the implementation of novel devices and technology. This approach is extremely important to the School of Medicine, and I think in a wider context. Multidisciplinarity from the earliest design stage to the final product, and the spirit of collaboration that tends to result in truly innovative outputs.